Chapter 9 review. When studying one variable, you can use a graph called a... So when you only have x's, well, we use a histogram and then we reference it to the normal curve if it's the right shape. So one variable gives you a histogram. And then two variables gives you they're called scatter plots, but this book calls them scatter diagrams. So scatter plot or scatter diagram. So does every one variable graph look like a normal curve? No. So we can graph a histogram, and hopefully we can turn that into a normal curve. If we can't, we have other ways of dealing with things. 2, true or false? If the correlation is negative 0.8, below average values of the dependent variable are associated with below average values of the independent. So if I have negative 0.8, what can you tell me about the graph? It's going down and the football is very thin. So it looks something like this. So if I take the averages, below average x's, that's the dependent, is represented by above average y's. Well, that's true, but the question is false because it says below average x's create below average y's. That's not true. Okay? So one way to think about positive slope is small x's mean small y's, and big x's mean big y's. That's called, those are proportional. Inversely proportional means as one goes up, the other goes down. And they don't move in the same direction. B, if y is usually less than x, the correlation coefficient between x and y will be negative. So if the y values are usually smaller than the x values, does that mean positive or negative? Okay, let's think about height and wingspan. So we put height on the x-axis and wingspan on the y-axis. So if everybody's wingspan is just a little bit lower than their height, would be positive. But what if we did height and weight? Well, let's do it. We'd have to do it the other way around. So if I graphed weight and height, where am I going to start on the weights? Like 90 pounds maybe? 90 up to maybe 250. And my heights are going to go from 50 to 75. She's not here. So the weights are all higher than the heights in this case. And I mean, whatever the graph was, it's still going to be true that the x's are bigger than the y's. So they're trying to trick you in this question. So it says, if y is usually less than x, the correlation coefficient between x and y will be negative. It could be anything. Because it's false. It could be anything, right? The independent variable might be in a unit that's totally different from the dependent variable. If your x is in pounds and your y is in inches, then everybody has a higher number for their pounds than they do for their height in inches. But the correlation could be in all sorts of directions, right? We're comparing two different variables. So that question doesn't make any sense at all. All right, 3. In each case, say whether which correlation is higher. So A, height at age 4 and height at age 18 versus height at age 16 and height at age 18. So which one has a higher correlation? Well, this has more to do with ecological factors. So if I did everybody from 14 to 18, it would look something like that. Agreed? So that would have a football that's pretty accurate. If I just limit myself to the last 2 years, that correlation is going to be weaker, right? Oh, that's what I tried to say. Oh, I didn't mean that. But that makes sense, right? Yeah. And it would probably be something more like this, right? When kids are born, they're all pretty well correlated, and then the older they get, the less correlated they are. But this football right here is not the same shape as the football for everybody. Okay, B. Height at age 4 and height at age 18 versus weight at age 4 and weight at age 18. I would say about the same. Okay. C. Height and weight at age 4, height and weight at age 18. Do you think 4-year-olds are more closely associated with height and weight, or 18-year-olds? And I would be interested to see the data, but I would say I would say 4, because my guess is it would look like a megaphone. My guess is the 4-year-olds are pretty close, and the 18-year-old, well, I need to turn that, but like this. That would be my guess. But it would be interesting to look at the data and see if we had the scatter plot, if we could look at it. So either age 4 or the same. I'm not sure which it is. An investigator collected data on heights and weights of college students. So men's height, women's height, and then their averages and their SDs for height and weight. The correlation coefficient between height and weight for men was about 0.6. For the women, it was about the same. If you take the men and the women together, the correlation between height and weight would be somewhat lower. How come? So, men would probably be up there, and women would probably be so. Well, you have to be careful of that because you're looking at averages, right? You're not looking at everybody. You're just looking at the average people. So there's the football for women. There's the football for men, and together, because men and women differ from each other, women are usually lighter per inch than men, right? So that's going to, when you put them together, it spreads it out. Do you remember when we did men's height and women's heights? So this was the normal curve for women's heights, and the men's height was slightly to the right. So this had an SD of like 3 inches, and this had an SD of 3 inches, but when you put them together, you end up with a normal curve that's wider, so that would have an SD of like 4. Same thing happens in this, except we're comparing 2 variables instead of 1. So this might have an R, this has an R value of 0.6, and this has an R value of 0.6, but taken together, we get an R value that's lower because they're more spread out. 0.5 maybe, yeah, that might be it. Okay. 5. A number is missing in each of the data sets below. If possible, fill in the blank to make R equal 1. If this is not possible, say why not. So what is the pattern in A from X to Y? So plus 0, plus 1, plus 1. Uh, what a we So let me graph this and show you. So 1, 1, and then 2, 3, right? Okay. So if I want a correlation of 1, it has to be on that line. What's the slope? Up 2 over 1. So up 2 over 1, up 2 over 1. So 3, this would be 3 comma 5, right? And then up 1, up 2 over 1, 4 comma 7. But the pattern is up 2 over 1, right? So we start at 1 comma 1, and then we move up to 1 comma 3, or 2 comma 3, and then 3, 5, and 4, 7. So you graph the points you have and draw a straight line, and your next point needs to land in that line, or the R value won't be 1. Okay, for the next graph. So 1, 1, 2, 3, and 3, 4. What's wrong with that? It's already not straight, so the R value is already less than 1. So there's no way to create a linear R value that will give you 1. There's no point that will work. A computer program prints out R for the two data sets shown below. Is the program working correctly? Did you plug those in and do a linear regression? Yeah, that's what I would do. I would stick them in your stat and then run a linear regression. Okay, so number 2 doesn't have, it gives an incorrect correlation. In 1910, Hiram Johnson entered the California gubernatorial primaries. What does gubernatorial mean? Governor. He's not running to be a goober. He's running to be a governor. For each county, data are available to show the percentage of native-born Americans in that county, as well as the percentage of the vote for Johnson. A political scientist calculated the correlation between these percentages. It is 0.5. Is it a fair measure of the extent to which Johnson received native as opposed to immigrant support? No. How come? 0.5 is not at all reliable. Right? 0.5 is approaching looking like a circle. So no. For age 25 and over in the U.S. in 2005, the relationship between age and educational level, years of schooling completed, can be summarized as follows. If your age is about 50, the average age is about 50 and the SD is about 16, and the average education level is about 13.2 with an SD of 3 and an R value of negative 0.2. True or false? And explain. As you get older, you become less educated. False. Certainly. If this statement is false, what accounts for the negative correlation? Why would older people have less education? So what this graph is, the x-axis is how many or how old are you, and the y-axis is the graph of how many years you attended school. Now you can't lose your education level. right? If you get a master's degree, even if you're in a coma, you still have a master's degree, right? So you can't go backwards in terms of education level. So why would older people be less educated than younger people? They didn't go to school as long back then. Yeah. Fewer people went to college. A lot of people got jobs right out of high school. Some people dropped out of high school to get jobs. I heard a comedian once say, he's old, he's probably in his 70s, and he said that when he graduated from college in 1960, all the dropouts already had all the jobs. Okay, so definitely false, and 80, 60, 70, 80 years ago, people did not attend school as long as we do now. They would graduate from high school at 15. That was common a long time ago. At the University of California, Berkeley, Statistics 2 is a large lecture course with small discussion sections led by teaching assistants. As part of a study, at the second to last lecture one term, the students were asked to fill out anonymous questionnaires rating the effectiveness of their teaching assistants by name and the course on the scale. So you don't understand what this means. In beginning classes at big universities, you will go to an auditorium with 5 to 900 people in there, and the professor will give a lecture once or twice a week, And then twice a week, you will meet in a classroom with a teaching assistant, which is usually a grad student, and they will teach and work with problems and answer questions and that sort of stuff. So half of your class is big lecture and half of your class is small group teaching assistants. So they wanted to find out which TAs were good and which TAs were bad. The following statistics were computed: the average rating of the assistants by the students in each section, the average rating of the course by the students in each section, the average score on the final for the students in each section. Results are shown below. Draw a scatter diagram for each pair of variables. There are 3 pairs. What are the 3 pairs? So it'd be assistant and course, assistant and final, and course and final. Okay? It doesn't matter what you choose for X and what you choose for Y? No, because the correlation coefficient will be the same either way. The data are section averages. Since the questionnaires were anonymous, it was not possible to link up student ratings with scores on individual basis. Student ability may be a confounding factor, however. Controlling for pre-test results turned out to make no difference in the analysis. Each assistant taught one section. True or false, and explain. On average, those sections that liked their TA did better on the final. And you can tell that by a positive correlation, right? As the light goes up, the scores go up. 9A on page 156. So what did you get for your correlations? So the 3 graphs are TA versus course, TA versus final, and final versus course. Did anybody get the values yet? Okay, let's do it. Here are the R values for each of those, and we'll explain them. So this is a very weak positive correlation, right? But in general, the more kids liked their TA, their course grade was higher. Okay? Or the other way around. The better their course grade, the more they like their TA. Doesn't matter which direction you take that in. And again, this is just a correlation. It's not causation. Well, so A is asking, oh, I'm on the wrong page. On average, the sections that liked their TA did better on the final. So these are the kids that liked their TAs, and as the liking of the TA goes up, the score on the final goes down. So B is false. A is false, sorry. Yep. Now, why might that be? Why might TAs that are liked end up having kids that don't do as well in the final? They were way too lenient. They didn't push them hard. Yeah. But the TAs who worked the kids really hard were not liked, and they did well on the test. So B, there was almost no relationship between the section's average rating of the assistant and the section's average rating of the course. True. 0.12 is a circle. And B, there was almost no relationship between the section's average rating of the course and the section's average rating for the final. 0.38. So let's go back to, go to chapter 8. It was on page 129. Okay. On 129, that first one we have a 0.3. Is that very well correlated? No. In fact, if you were to throw that top point out, it would pretty much be a circle. So 0.38 is not very much, it's not a very good correlation. Yes. 10. In a study of 2005 math SAT scores, the Educational Testing Service computed the average for each of the 51 states from the percentage of the high school seniors in that state who took the test. The correlation between these two variables was equal to negative 0.84. Do you see a problem? They're graphing 50 averages. 51 averages, because we've got to include DC. Okay, that's always a problem. When you correlate averages, the correlation is going to be higher. 9C was true. So 10A, true or false? Test scores tend to be lower in the states where a higher percentage of the students take the test. If true, how do you explain this? So first off, true or false? Lower scores meant more people taking the test. So, well, so here is the number of tests and the scores, right? And we have a negative 0.84 correlation, which would be this. So let me read that again. Test scores tend to be lower in the states where a higher percentages of the students take the test. That is true. The more kids take the test, the worse the scores, the average scores are. Now, this happened in Utah with the ACT. 5 years ago, the ACT was not required as a junior. It was optional. And then the state of Utah had this brilliant idea that they're going to let everybody take the ACT and they're going to pay for it. And the scores went down and they said, uh-oh, why did the scores go down? Well, it's really easy. There were a bunch of people who never intended to take the ACT or go to college. And now those people are forced to take the test. And they're going to do worse on the test, one, because they didn't care, and two, because they already knew they were going to get a bad score on the test, so they didn't take it. So the more people take the test, the worse the average gets. B. In Connecticut, the average score was only 517, but in Iowa, the average score was 608. True or false? The data show that on average, the schools in Iowa are doing a better job at teaching math than the schools in Connecticut. So let's get everybody in on this discussion. So Iowa had a higher score than Connecticut. Does that tell us that schools in Iowa are doing a better job at teaching math than the schools in Connecticut? Well, as a math teacher, I'm going to say false. They are doing a better job at preparing kids for the ACT test than the schools in Connecticut. It doesn't mean they're teaching mathematics better because the test does not grade mathematics. It grades the ability to score well on the test. Average won't, average would clear that out because they're averaging it, so that's not an argument. I don't think there are. Landon, you want to run and grab some? Quit picking your nose and it wouldn't bleed. Okay, 11. As part of the study described in exercise 10, the Educational Testing Service computed the average verbal SAT score for each state, as well as the average math SAT for each state. The correlation between the 51 pairs of average was 0.97. Would the correlation between the math SAT and the verbal SAT computed from all the data on all individuals who took the test be larger than 0.97, about 0.97, or less than 0.97? Probably quite a bit less. The averages of all of the states were pretty similar, but there's a lot of variability within each state, so it would be lower than 0.97. Okay, and 12. Shown below is a scatter diagram for educational levels. A, the points make vertical and horizontal stripes. Why? Rounding. Yeah. Well, and everybody rounds it. They don't. People usually do finish the year. That's true. But even if you don't finish the year, you don't say I went to 12 and a quarter years of schooling. Right? They just round it. They either finish it a whole year or they round it. B, there were 530 couples in the sample, and there is a dot for each couple, but if you count, there are only 104 dots. Why? Yeah, there are some of those dots contain 2, 3, 4, 5, 6, 7, 12 of the same points. And three areas are shaded. Match the area with the description. So 1, wife completed 16 years of schooling. Which graph is that? C. Wife completed more years of schooling than the husband. I don't see one that has wife completes more years than husband. Husband completed more than 16. That would be B. Husband completed 12 years of schooling and wife completed fewer years of schooling than husband. That would be A. All right, we're done.